Okay. I'm going to miss Marisa because even on my worst days, she was always so kind and so gracious to appear to laugh at my worst jokes. So, and with that, I turn it over to you.
Thank you. Well, first I would like to thank you guys all for being here. It really means a lot that you guys took time out of your days to come see the presentation. As Perry said, my name is Marisa, as most of you should know, and my thesis is fish tank helper. So to define the problem, pH is extremely important when it comes to fish. And if you guys don't know, pH is the level of acidity or basicness of something. Changes in pH are really harmful for fish, and in a lot of environments there are certain species of fish that aren't even able to breed within certain pH levels, and a incorrect pH level in the water could cause fish to become ill. pH needs to be tested pretty often. Anytime there's a fish illness and you treat your tank with medication, you want to make sure that the levels are good when the treatment has first started, on the final day of treatment, and 1 week after treatment, just to make sure that the medication didn't mess with the pH levels too much. And then every time you add a new fish into your environment, you want to make sure that the pH levels are good. So there are some current solutions to checking the pH levels of your tank. The most popular one, I believe, is to just collect a water sample from your tank and bringing it to any pet store. Most pet stores offer free pH testing, but if you have a lot of tanks, one of the inspirations for my thesis was actually my dad. I grew up in a house with over 10 fish tanks. He had fish tanks built into the wall. He was all about just creating environments for fish, and if you have that many tanks, it's really time consuming to collect samples from each tank and having to bring them all to the store to be tested. And then another solution is to test it in your own home. You have to purchase a pH tester, which works, but there are chemicals involved in that, and as you could see from the photo example, that you don't get a complete accurate reading. It's kind of hard to tell exactly what the pH level is based off of that color. So the goals for my project was to obtain the pH level without having to use chemicals or bring a water sample off-site. And I wanted to provide a way for constant testing that's accessible from any mobile device. So my solution, my thesis is Fish Tank Helper, which is a hardware-software combination that continuously tests the pH level in water, and that is combined with a mobile application that is connected to my database that provides a way for the user to view the levels of their water. So the major pieces that I will get more into are the microcontroller, the sensor, the database, and the user application, which is the Android app, and just general flow of data from the water. The sensors takes the information, and the microcontroller then sends that information through the serial connection on my laptop to a Python script, which through PySerial sends it, or Firebase sends it to Firebase, which is the database that I chose to use. And from then, the user can view that information on the Android application. So the sensor that I chose to use was this analog pH sensor. It was a little bit more expensive than a lot of the sensors on the market, but the reason that I chose to use this one was because you could actually keep it in the water for a long amount of time. All the other sensors, you could keep it in the water for a little bit, and then you would have to take it out and store it in a solution. And I wanted it to be constantly monitoring the water. The microcontroller that I chose to use was an Arduino, and the Arduino really interested me mostly because I went to all the thesis presentations last year, and a lot of people chose to use Arduino, and I was extremely impressed with what people came up with, so I really wanted to use some type of hardware and use the Arduino in my own project. It's really easy for a lot of people to upload code to. There's an Arduino IDE, so you could write code right on your laptop and then upload it right to the board. And the purpose of the microcontroller in my project is to retrieve the data from the sensors, and then from then it pushes to the Python script, which will send that information to the database. And the database that I chose to use was Firebase, which is free cloud storage provided by Google. It receives the data and then pushes it to the mobile application. Another cool thing about Firebase is it does have built-in email password authentication, so I didn't have to write that on my own. And the mobile app, which is the actual user application that people are going to be able to view the levels of their water on. I chose an Android application just because I don't have a Mac and I have an Android phone, so I figured testing would be a lot easier, but this could easily be written for an iOS app as well. So the app receives and presents the information from the Firebase, and then it'll also give you a little notification if your water is outside safe levels. So I'll go right into the demo. So this is my Android application. At first, I'm going to log in. I already have an account, so I'm not going to go through the registering process. And then once I run this Python script, the sensor information is starting in real time to be set up to the database. And if you click on your tank, you're able to view the pH level of your tank, and it changes in real time. For demonstration purposes, I have it so every 20 or so seconds it'll send up false data just right here, just to prove that it notifies you when the levels are too high. I just have that on right now because obviously I have a fish in here and I didn't want to kill it for my demonstration. But yes, that's it for the demo. So I've really fallen in love with my project after working on it for a while, and this is definitely something that I do want to continue working on and making better, because I would like to gift it to my dad eventually and let him use on his tanks. I would like to add Wi-Fi capabilities, so as opposed to the microcontroller being connected to the laptop and sending that information through the serial connection to Firebase, I would like it so the Arduino on its own, while connected to a power source, is constantly sending that information up. And I would also like to add a few more sensors, temperature being the main one, because temp is also extremely important in your fish's environment. And then I would have to do more research on whether or not sensors like this exist, but if there were sensors to read the oxygen level in the water to make sure that that's up to par. And then I think it would be really cool if I could hook up my database and application to some type of R script that will take all of the readings and make graphs for you, so you could see if there's any specific times where there's more of a spike or a dip in pH than usual. So for my reflection, I learned a lot about working with hardware and new languages. I really wanted to step out of my comfort zone and work with something that I had never done before. I've never made an Android application, never worked with hardware or anything like that, and I've learned that you could plan all you want, you could do as much research, and you could think that you know how long something's going to take, but you're never going to know how long anything is going to take to complete until you actually dive right in and get to doing the work. There could be something in your head that you think is only going to take a day or two to implement, but then have it end up taking a week, and vice versa. There could be a problem that you think is going to take a week to figure out, but then you sit down and get it done in a day. A piece of advice, I don't know if there's many underclassmen here right now, but definitely take advantage of all of the resources that we have here at Carthage. We have such an amazing sense of community in our comp sci department. We have things like the barbecues, and I just think that definitely use that to your advantage. And then more of a personal reflection, I learned a lot about myself in the year that I was working on this project. Before this year, I kind of felt as if maybe I didn't really belong in the computer science field. I felt kind of different from all of my colleagues, like maybe I wasn't smart enough. But that's why I really decided to challenge myself and convince myself that if I'm having an issue, that I'm actually smart enough to be able to sit down and get that figured out. And I have learned that if I hit a wall, I have to not let that shut me down. The more that I just get shut down, the more time it's taking where nothing is being worked on. So just make sure, even if you think that you've hit a wall and that there's no solution, just keep working towards it. It's the most satisfying feeling in the world to be working on a bug for days, and then when it finally starts to work, it's just an amazing feeling. And definitely, if you believe that you're not smart enough for something or if that you're not going to be able to get it, just make sure to push yourself, because you would be really surprised at what you could do. Any questions? Yes.
Do you happen to know if Android apps can they kind of like run in the background 24/7 and receive these notifications from like Firebase or somewhere else?
Yeah, I believe they can.
So the app wouldn't have to be open all the time in order to get the updates?
No, because as soon as you open the app, even if it did shut down, if it wasn't getting it all the time, once you logged in, it would start receiving that information.
But you think their apps can sort of sit in the background?
I believe so, yes. Yeah.
How is the pH tester connected to the Arduino?
I could show you if you want, but just through these wires into like the separate pins of the Arduino.
Okay.
But I could show you later, get more into it. Andrew.
You were talking about why you picked that pH sensor over the other ones.
Mm-hmm.
Are there other models of pH sensors and things like that that's compatible with?
Yeah, there are other pH sensors, like I said, that you are able to place in the water, but they're not able to stay in the water. You have to remove them and put them in a solution right away. And my code, I believe, would be compatible with those because I think they're made by the same company that makes this sensor. So if I wanted to, I could just switch it up. But for what I wanted to do, I thought that it constantly being able to test made more sense.
So you had mentioned like the litmus strips have chemicals in them, which A, wasn't as accurate, and also you don't want to be putting chemicals in your water. So what is that used if it doesn't use chemicals? Like how is it measuring the pH in the water? That's beyond the scope of your
Yeah, I didn't actually create the hardware myself, so I don't know like the technicalities of how exactly it works and how it's reading the water, but that is a good question.
Okay. Seniors, don't go.